So if you're following along, you should be able to run that command. And what that'll do is it'll let you know that the agent has started, and then you run the command to add the key to the agent. So I'm going to take this here, and I'm going to just do, instead of the IDRSA, I'm going to do text, because that's the one that I created. And so it went ahead and added it for me. I'm not sure why the agent's not running. But basically, I've created a private and a public pair. I'm adding it to my SSH agent, and now I need to go and add the public part to GitHub, so that GitHub and my computer can now reference the same pair. If you're on a Mac, there's a nice utility for copying stuff to the clipboard. I'm going to do that because it's a pretty long string there. So I'm just going, I'm going to take whatever's in test.pub, copy it to my clipboard, and now I'm going to go to GitHub and add that to my account. Now, it's also kind of nice on GitHub, your SSH authentication is tied to your account and not your organization. So I'll upload it to my GitHub account, and it'll work for if I'm pushing or pulling from the Norfolk Data Science organization or any other organization I'm part of. So I'm going into settings, SSH in GPG keys, and then I'm going to add a new SSH key. I'm going to call it DataSci, copy, add the SSH key, then I put my password. And now I've added a new SSH key, and I'm good to go. I can push and pull securely to any repository. And so from there, I'm going to go create a new repository.
Do you just want to take a second and does anybody have any questions about, are you running into any issues with creating your key or understanding what a key is, anything like that?
Are there any questions there?
Where to put the key? So, like, he went to github.com and copied and pasted the contents of this file into GitHub. So your key has two parts, a private part and a public part. The private part needs to stay on your computer because that's yours. The public part goes on all the other servers you want to connect to. And that's what he's doing, is taking the public part, the file that ends in .pub, and putting it on GitHub servers so that GitHub can authenticate that it's really him. He's got the private part, public part GitHub has, and they know anytime Josiah wants to make something, push it up to the server, they can verify that it's him as an individual. That's the security sort of feature.
And specific to the machine that you're on, because any computer that you want to authenticate with has to have that file in the SSH agent. So that's one of the advantages over HTTPS. From HTTPS, it doesn't really check the computer, it just checks the login credentials. But if you're authenticating with SSH, it's specific to the computer. So now that I've done that, I'm going to make a directory on my computer really quick. Just kind of separate the work that I'm doing. I'm going to go into the GitHub repo, and I'm going to create a new repository. So I'm going to create one in the Norfolk Data Science. New repository, members. You want to name, whenever you're working with Git and GitHub, you want to make sure your repositories are using the same name, because what I have on my machine is going to be the local copy, and then I'm going to be syncing that to the remote copy. So I'm creating members here. And GitHub is really great just as a website because it really walks you through everything. So I've created a new repository, and it goes ahead and gives me all of the commands I need to get started locally. So I'm going to copy these here, take those down, run them, and we'll go over what those commands mean in a second. But if I refresh the page here, so I just copied the commands they gave me and ran them on my local computer, and now I have that members markdown file that I just created locally synced up to the remote repository, and I didn't have to do any authentication, right? I didn't prompt for a password or anything there because I set up the SSH keys. So it's pretty, once you have it set up, it's pretty seamless.
I'm going to steal your thunder for 1 second.
And those are the commands that I run there. So let's go through those more slowly. In the first command that I ran, the git init, in the directory that I want to sync to my project, that's like the way I think of it is you're installing Git into that directory. Now, once I've run Git init, it creates a .git file, and now I can use Git commands. If you go into a repository that doesn't have that ran, so I'll just go out and I'll go into, I have Git in pretty much everything now. Let's just say I want to do Git status in this directory. Fatal, not a Git repository because I haven't ran Git init yet. But if I go into members, where I ran that command, if I do Git status, it'll tell me my branch is up to date with origin master, nothing commit. So I've essentially installed Git into the directory and I can now use it. We created the README file by just echoing some text to a .md, and then I did git add over here, up here. Git add is the equivalent of saying, okay, these are the files in this directory that I want Git to start tracking. It doesn't actually save any of the changes. It just says these are the files I want you to pay attention to. So when you install Git, when you get init into a directory, you don't have to track all the files. Not all of the files have to be a part of your project. You can actually exclude certain files and say, okay, I don't want to track these files. I don't want them to be committed to my remote repository. A good example of that would be what if you had a file that had some passwords or some configurations in it that you're going to use locally for working on the project, but you don't want to push that out. So git add says, okay, track the readme.md file, and then I'm going to do a commit. The commit says, anything that's changed in this file, go ahead and commit it to the Git, like take a snapshot of what's happened. And once we've committed the changes, now they're tracked. The git tag-m is saying, what's the message that's going to go with this commit? And this is really important because it's me explaining what did I do to this file, what's different, what's important about this commit, so that one, I can remind myself, and then two, if I'm working with other people, they can come in and they can look at what's going on. So you add the commit message, and then finally, so locally, we've committed the change, we've tracked it, we're good to go. Now I need to sync it to the remote repository. So to do that, I have to add a remote first and say, where is the remote location where I'm going to be synced up to? So I do the git remote add, and I choose a name for the remote repository. The normal convention there is origin, because the remote repository is going to be the authoritative source. So I'm going to call that origin on GitHub, git@github.com, the username, which for us is Norfolk Data Science, because that's the organization that the repo is under, and the name of the repo that we're syncing to. Once I've added the remote, finally I push and I sync up. So I say take all of my commits and changes that I've done locally, push them up to the remote origin that I just defined, so that's going to be origin, and the branch name, which is master. You have to push to a branch that already exists, and when you create a repo, it automatically starts with master over here. So we're on branch master. So those are the commands that I ran to sync up. From there, I'm going to go ahead and add some stuff to the README file locally. So let's open the members file. I'm going to add save. So I've made a change to a file locally, but I'm not tracking it. I'm not doing anything with it in Git. So if I look at Git status, it'll say that file that we're watching was modified, so I need to add it. The git add dot is just saying add all the files in here, but I can also specify it by name. I can say git add readme. And if you don't want to track all the files, then you go through by name, or you can use like wildcards. So I'm just going to do git dot. And then now that tells me, okay, this change is ready to be committed. We've tracked that you changed the README file. It's in green now. It's ready to commit. So I'm going to say git commit, and my commit message, update README, and then I'm going to do a second line. So if I see I did the tag-m, that's going to be the subject of the commit message. I'm going to do tag-m again, and I'm going to say add Josiah's name, so people see what's here. And now it tells me, okay, you changed the file, you there was one file change, 2 insertions, and I've committed my changes. So if I do git status now, it says my branch is up to date with origin master. This is all still local though. It's just tracking everything local. So to finish, I'm going to do that last command where I'm git push to origin, which is the remote that I set up. It could be anything. I could call it git push Norfolk data side, but the convention would be origin, and I'm going to push it to the master branch. Git push origin master. And now if I go over here and refresh, it's going to have my update. And then you can see that it'll tell me there was a commit that's done. And this, let's look at this. If I look at the commit history, it gives that first line, that TACDAM update readme becomes the subject, and then the second line becomes the description. And that's a good practice to get into. Title your commit message very descriptively, like what exactly was going on here, and then go an explanation underneath, not so much of what you did, but why you did it. Why is this commit important? So it was update the readme was what I did, and the reason I did it was I needed to add my name there so people would know that I was working in the file.
Yeah, so just to sort of recap what his workflow is like he has a file that he wants to change, right? It's readme. He just wants to add his name in the file. He did it, and then he ran those commands, add, commit, push, to actually make it show up on the server and back it up. So if you're using Git as like a backup of your work, right, you're going to have to make the change locally. At some point, you're going to have to push it up to the server. And that's what this is saying. It's like, I want to add all my files to be pushed out. I'm just adding a message about what I changed, and then I'm actually pushing it up to that server. And that's what he's essentially showing. So as you get more complicated, you have more files. You just add more files and just keep pushing them up and up and up.
Right. And so if I was just using this locally and not interested in collaborating with anybody, I would probably just do git add and git commit. And that would be a way of me notating my own work. I would say, okay, I'm going to change the file, add it, commit it to the history, give an explanation of why I did that. And what I can do, if I'm writing good commit messages, I can go in here and do git log, and it'll give me a history of what's been happening. It'll say, okay, on this date, decided the first commit, and all he had was a title and a description, and then he followed up with an update readme, and why did he update the readme? Oh, it's to add his name. And so that's all I can keep track of that locally. That's also synced up to what's here, because we can go into the commit log here, and you're going to see the same thing. So let's say Steve wants to come into the project now. He's going to go to the repository and be like, okay, well, so I did a commit, and he updated the readme. Why did he update the readme? There's the explanation of it, and then the file that I changed. So you're keeping your own personal history, but you're also sharing that with other people, which is really important. So now let's pretend like I wasn't the one working on this, and I actually want to pull down this repo. And this is how you actually get. So this is me working locally and pushing up. Now I'm doing the other side of that. I don't have anything locally, and I want to get the work that somebody else did, and that's called cloning. So I'm going to make a new repo, or a new folder here. My repo. Now I've created a new folder, and I'm going to run this command, git clone, and the reference to where it's at. And because I'm doing SSH as my authentication, the syntax is a little bit different than HTTPS. If I was authenticating with HTTPS, I would say HTTPS, github.com, Norfolk data side, members.git. I use the actual URL, but since it's SSH, it's git at GitHub. It's like the user at the source, and then the path. That's just a minor thing.
Do you want to show them where they can find that link on the repository?
Yeah. If you didn't know where that was, you can always go here to the repository, hit clone or download, and it'll tell you cloning with HTTPS is right here. That's the link, and you can copy it to clipboard. And then there's also use SSH, and I can get that. So let's say I'm browsing the folder here. I say, okay, I want to clone this repo locally so I can work on it. I come here, I hit copy to clipboard, go down here, and I'm in this repo called my repo, which is empty right now. I'm going to say git clone this repository. Oh, this is what you were talking about.
Yeah.
The library.
Yeah. So I can show this part.
No, let me. There's something about the library Wi-Fi that does. Let me just try this real quick.
Yeah, if you connect over VPN, you'll be fine.
It's wonderful library internet.
Do you want to make me presenter for a moment?
This will take like
Okay.
less than half a second.
So, like, Josiah has a repository on GitHub. If you see a GitHub repository you like, you want to look at the code, you want to work on it, see what it's all about. That's what he's showing now, is like that clone URL. You say git clone that URL, that string. That's how you get it down onto your computer. So on a server, you pull it down.
So now I'm connected to VPN, not using theirs. I did git clone, it said receiving object, checking connectivity done. Now if I check the folder, the files in the directory, I have the members folder, and if I go into there, I have the README file, and I have all of the up-to-date changes that were committed on the other one. So remember, this was not where I was working. It worked, pushed them up, went to a new place and pulled them down, and that's the workflow. The remote repository is always going to be the source of where everyone should be pulling from, doing local changes to, and pushing back up to. Wow,
Yeah.
we'll talk about that.
We can talk about that.
So from there, so now I've got a folder on my computer and I'm doing things. Steve's got a folder, maybe he wants to get involved in the project. Steve's cloned the members repo, and we're working together. That's where you start to run into things called merge conflicts, where we're both working at the same time. What happens when we do things that collide? Like I put text on a line, and then he comes and puts text on the same line, and we're working at the same time and we both push up. That's one of the other things that Git is great for. It's great at managing all of that for you and giving you a process on how to deal with that. Because ideally, I would say I'm going to work on it on Monday, Tuesday, and you're going to work on it Wednesday, Friday. On Monday, Tuesday, I do all my work, and I push it all up, and I say, all right, everything I did is up to date, and you go, great, and you go get clone or get pull, you pull all the changes down, and he starts to work. But that's not normally what in a perfect world. That's not normally what happens. Usually we're working collaboratively or we're not talking to each other, we're just working independently of each other, and we'll push up and he'll push up. So we're going to demonstrate a little bit of what that looks like, and I'll turn the presentation over to you real quick. So that should be you.
Yeah. All right. So to give an example of what Josiah is talking about, I have that same repository on my computer, and so I did the same steps he did. I cloned it locally, and I have this same file that's called readme.md. And if I try to edit this file as well, like I want to put my name now as well. Josiah added his. I want to add mine. We're both working on this project independently of each other, and I can follow the same steps that he did when he was entering commands. So those commands that were git add, git commit, git push, I'm going to run those same exact commands with my change. He added his name, I'm going to add my name. And so what happens is that I do git add and I do git commit and then I do git push, and then I get something back that's a lot longer that says my updates were rejected because the remote contains work that you do not have locally. And I've got the same message here in the slides if you want to look a little bit closer. And what that's really telling you is that, making you aware is that your local changes, the server knows nothing about. So if someone like Josiah is making all these changes and changing it on the server, and I'm just working away at my computer, it has no idea of everything that's been changed. So when I go to push something up there, Git automatically stops you and says, there's been updates you don't even know about up on the server. You should actually try to pull them down on your computer. And so they'll actually warn you and tell you, and they even say the word in, run git pull. Like they tell you, run this command because you should do it.
It's like the best error message you can ever get. Here's the problem, here's what you need to do to fix it.
So you can follow the hint and run this command, right? So I'll take this command and run that next. And so what's funny about it is then you receive another message, and it says conflict in all caps. And it says, again, a nice little hint. It says fix the conflict and then commit. So what is a conflict? It's when I change something and Josiah changes something. Git is a very passive arbiter about what should be right or am I right? Is my change the right one or is his one the right one? Nobody really knows. But what Git says is that, hey, there's like a problem. You guys are both out of sync and you're both trying to change the same file. So like, who's right? And so what happens is that if you open up the conflicted file, so in this case it's the readme.md file, you'll notice some really weird markings.
And those are things that Git just added to the file.
And I did nothing. I didn't add these at all. Git actually said, hey, here's what you've done. What I've done is called head. Head is the most recent commit that I've made locally. And it's saying, this is what I've added. Everything below the equal signs are what Josiah has added in this commit. So every commit gets assigned a unique ID called a hash. And it tells me for this particular commit that he made, this is what he had done. So I can see in my files, like, what's the difference that we're trying to reconcile here. And when you have a merge conflict, fixing it really just means fix the file, change it, edit it, so that it's whatever you want it to be. So if I really think my change is the right one, I don't want Josiah's name in there, I just remove it from the file. And then save it, and I know this is the one I really want to go up on the server. So I will run the same commands that we do when we want to push stuff up to the server. Git add, git commit, and I'll say fix the merge conflict, and then git push. And that all works fine at that point. So when you look up at the history of our project, you can see the changes that Josiah made were he first made a commit to create the README. He then updated the README with his name. If you want to just double check that's what he actually did, click on the commit, and you can actually see in green, these are the two lines he highlighted, right? So if you then go up to the next commit, let me go back. Yeah. I don't think you go to parent. So here's my one commit where I added my name, and then here's the commit I had that actually fixed the conflict that both of us had. So it could be not uncommon that you're actually working with someone and you get messages like this from Git that are giving you like errors, there's conflicts, or whatever those are. Don't be scared about those messages. Just do exactly what they say, and you'll be fine.
Right.
So
just like as a quick recap, it's not actually when I was first using Git and GitHub, this freaked me out. I was like, I don't know what's going on. It's giving me an error message. I wrote something. It's really not actually, right? And even thinking of it as an error message might be the wrong way to think about it. It's just talking through the process of working with somebody else. So you do some work, you try to push it. Git says you can't push this because there's work ahead of you, and you need to look at it first before you do. And then it tells you, go ahead and do a git pull. So you do a git pull. When it pulls down that stuff, Git will automatically try to fix the conflict for you. So let's say that Steve had added a completely new file that I had never touched. Git would still warn him when he tried to push. Hey, there's work in the remote that you don't have locally. You should check that out first. You do a git pull, Git pull would pull the new file down and be like, okay, Steve hasn't done anything to this file. This is a brand new file. I'm just going to add it into the directory and allow him to continue his work, and there wouldn't ever be a merge conflict, right? So just warning you, stop, figure out what's going on. In our case, we were both working on the same file. Git recognized that, found the exact spot where the conflict was, annotated it for him, and then told him in the message, here's the file you need to go look at. So it's pretty much saying, do a git pull, I'll find the problem for you, and I'll tell you where to go look for it. So it said, in the README there's a conflict, you open the README file, and they had it very clearly marked, here are the offending lines of code. Now, if you do a ton of work, and he's done 3 days of work, there might be a ton of commit messages for him to fix. Which is why if you're working, you want to get in the practice of bite-sized work. Anytime I do something like a complete thought or a complete idea, I want to go ahead and commit it and push it. Because that will keep you from getting into just a merge nightmare where it's like, oh, there's 700 merge conflicts, and you have to go through each one of them. Because the important thing here is, like he said, Git is a passive arbiter. It's not going to decide Steve's changes are better than Josiah's changes. It's only going to highlight those differences for you, tell you where they are, and then you have to go through and you have to manually fix every single one of them. So good practice is avoid that situation by doing things in very simple, easy to understand steps. And I think one of the ways you train yourself to do that is writing really clear, concise commit messages, right? If you have to have 3 subpoints in a commit message, okay, in this commit, I did this, and then I did this, and then I also did this unrelated thing over here, maybe you should start to think about how could I break this commit, long commit, up into 3 small commits. A commit should have a subject, I did one thing, and then an explanation of why I did it. And if you get in that practice of committing often and describing your commits as single actions, update README. Why should I update the README? To add my name, okay? And then he updates the README again, and that would be a separate commit of add contact info. And that would be better as add my name, commit. Add contact info, commit. Rather than updated the README, added my name and contact info, and then created a whole new file for blah. And that's how we can kind of like manage and really let Git do most of the work for us by identifying the conflicts and highlighting them.
The example that you guys walked through, if you, since you're both here, if you had just deleted all the extraneous, hash marks and everything, and left that you both were here, would you accept?
Yep. Sure.
All it's really looking for is for you to say, this is okay.
Yep.
And clean it up a little bit.
Absolutely.
Yeah. So you could save the file with all those weird marks in it. Why not? The thing is, if it's code, it's probably not syntactically correct code that executes anymore. That's like gobbledygook, right? To your interpreter or to whatever language is running the code. You're going to want to remove it, right? But there's nothing stopping it. Any change from here, it lets you do, right?
So then it's really just looking for you to approve it.
Yeah, essentially, yeah.
And then move on.
Yeah.
And the scary part, though, is you can approve however you want. It's going to keep a trail of what he did.
Yep.
So you can
Well, actually, go back to the,
But I mean, you can make whatever changes you want, but then when you go back, you've got to go then and rechange it.
Yeah.
And then,
click on his,
right? I mean,
yeah.
That's what we'll do
because if
next.
a third person comes on, they're going to see his
Yeah.
final version as the most recent
So,
So I can actually come in here and I can even comment on this.
yeah.
Right? I could come in and I could see that this was is this the merge, is this the fix?
Yeah.
Go to the other one where you add your name. Yeah, that's your local one. Go to the merge conflict one. But if it's all in the history, yeah, exactly. Everything you get is captured. That's what enables us to actually work collaboratively. I can see a history of everything that was done.
This one?
Yeah, I can come into GitHub now, and I can say, well, this is different from mine. I can reference the hash, and I could write a note right there and be like, hey man, why'd you do that? Why did you leave both of our names? And we could start a conversation.
How important is it to have rules of engagement between whoever's working on a project, so that you know who kind of has authorization to make a significant change or minor change?
We'll talk about that. That's kind of where we're going.
It's a little bit, but I will say, it's important, but let Git do it for you. right?
Yeah.
That's part of the reason of using a tool like Git. We don't have to sit down and set up a schedule of when we're allowed to work.
Sure.
We don't have to decide. We do have to kind of define the process of maybe resolving conflicts, which we'll talk about, which Git also gives us a tool for doing that. But the reason for using a tool like Git for working collaboratively with people is to cut down on that, so that I don't have to think about that. I can just jump in. I've never met Steve before in my life. I don't know his telephone number. I don't even know where he lives. I just know that he's a report more on GitHub. I can clone the repository. I can start working away. And that's kind of like in data science and open source and things that are more community-based. We may not be able to ever meet and sit down and figure out what those rules are. So we want to let the software do as much of that arbitration for us as we can.
Yeah. So, I mean, one good example or feature of Git is all the commenting that Josiah brought up. So you can make a comment on the entire commit or on a particular line. Josiah could come in here and, you know, just talk to anyone. Here's Joe. Joe's sitting right here. I could just say, hey, Joe, why do you think we should include Josiah here? Right? He's dumb. Try not to be a bully. But now that's in line, and someone can reply, Joey or even Josiah, anyone can reply and see what's happening, right? They could see that in my commit I've erased Josiah's name from what was the previous work, and we can all talk about it. So let's say that was actually a mistake. I shouldn't have erased Josiah's name. And I want to basically go back to the state of the file that he had before I did my part. And so that's the next slide in the presentation is how do you fix or reset work? So it's actually possible to erase commits back to any point in time. So in the GitHub interface, there's the little button that shows the number of commits. When you click on it, you see a particular commit. There's this hash. Remember how I said before that every commit has a unique identifier. And so if you run this command, git reset hard, and then the hash number, it'll take your history of commits, your string, back to that particular one point in time. So I go here, and I want to get rid of these now. I just click on the copy clipboard function to get this particular hash for Josiah's last commit. And if I go back to my repository, I just run that command, git reset hard, and add the hash there. And now it tells me that the head is at that particular commit.
Remember what you said about head. Head is the most up-to-date commit. So it's saying roll back to this point in time.
And that's only on my local machine, though. So the server still knows nothing about me resetting stuff back. So I need to actually push the change. This is a real change. Push it back up to the server. The thing about if I were just to run git push, there will be that same stinking message that we got before that was that the server has changes that you don't have. And if you think about it, the server has 4 commits. I basically reset back to 2, and now when I try to push it, it's like, oh, there's those 4 up there, you only have 2. Try to get them. And I'm like, oh, no way, I know about those 2. Those are not the ones I want anymore. And you can override git by using a force. And so this, if you do git push tag force, tag F, that will actually force this change up onto GitHub, even though Git has more stuff than I have. I know better, so I'll push it up and force it up. And then what happens is those 4 commits, they'll go back down to only 2 commits. Because remember, I took this one and I said go back to this particular point in time. So that history that I had of like adding that commit, adding my name and merging it, it's gone now.
So that changes the whole audit trail.
Yes.
Could you do that could you have done that and erased his and gotten the same thing, or did it accept those changes because you were deleting commits that you had made?
It's not user specific, no, that reset.
You could wipe out a lot. So this is for illustration purposes only.
Yeah.
Right. Well, don't follow this type of workflow because this just demonstrates very quickly. Hey, we can roll back and we can update everybody to the rollback point. There's much better ways to do this that preserve the audit trail. Okay. But it's a little bit out of the scope of this talk. But the purpose of Git is that you don't lose anything. You'd never lose any history of work done on the project. So even if we want to roll back to a specific point, we can do that in such a way that the history is preserved. It would have just taken probably 15 minutes to walk through versus the 2 episodes. But the key point is, he went into the history, he referenced a certain hash or a commit, and said, okay, take me back to that point in history, and Git took him to that point in history exactly how it was. It's a perfect recreation of where we were at that point.
Yeah, and you can actually see, so my editor prompts me that this file has been modified, and it's been modified because I basically reset it back to Josiah's version, which is really hidden in here. So I'll tell you, it's not good to use Git reset, but I've used it plenty of times when I started learning. I put something up there that I shouldn't have, or it didn't make any sense, and I just don't want anyone to remember that. I just get rid of it. It's not a terrible command, but you got to be careful when you start working with other people, not to erase each other's work. So we'll talk about how to actually work alongside people in a less sort of friction way that we had seen previously. So typically the way people work when they work on code together is to create branches. So a branch is a copy of code that's separate from another version of the code. And typically people will take a copy, do their work, and then move it back. And take another copy, do some more work, move it back. And the reason for that is it decouples what you're working on currently from the main code base that should always be working. So if you're testing something new, test it on a branch. Do your work, and then bring it back to the master. That's kind of what the flow is. And so this could have prevented a lot of the merge conflicts we had seen previously if I had started working on a branch. And that's, again, just a copy of the current state of the project. So to start a branch, you need to run the command git checkout tag B, and then give it a name like my branch. The tag B just stands for check out a branch. This is a particular type of code you're checking out. It's just a copy of my master. So check out my branch, and then Git will tell you, switch to a new branch. It's tracking master. It came from there, so it's an exact copy of it. And I can now work on the file there. So it's only local when you create it. You got to still remember everything you do local has to be pushed back up. So I'll run a command that pushes this branch up to the server. Because right now, if you went to the branches listed in this repository, my branch doesn't exist. Right? There's only one branch in this repository. But as soon as I do git push origin my branch, I can check. And now on GitHub, there's 2 branches part of this repository. So again, remember, everything you do locally has got to be pushed back up. Now I can change the README file however I like, right? I'm on my own experimental version of the code called my branch, right? And I can just say this is, an experiment. And go through the normal routine I typically do when I want to push a file to the server. Just do git commit, new change, and then push it up. And if you want to see on the master, that's the version. If I go over to my branch, you see it's a slightly different version. It's got my this is an experiment line added to it. So right now we actually have 2 versions of code running now. We have this one that's what we originally created, and now this new experimental branch, this new experimental version that I'm working on that's got some new lines in it that are interesting. So the interesting thing on top of that is that if you were to look at the file on my computer, there's just one file. I'm just changing this file. And it's got my new experimental version. But if I do git checkout master, which is the other branch, it'll tell me this file's changed, and it'll go back to the master one. And in the file system, it's still only one file. So if you think about how you might be doing stuff at work now or at home, you might have a Word document, and it probably says first version. And then you've got another, it's like first version with this date. And then it's like first version plus this. And then it's like first version plus final version. And then it's like, this is my last one. You've got like 10 Word documents that are all the same. Those all could be different branches or whatever. They would just be one file on your computer in Git. That's kind of the beauty about branching is code is really complicated, right? If you think like collaborating on a paper with someone is hard, imagine collaborating on compiling code. Like, it's crazy, right? So the way you actually think about it in your head is there's one branch that always works, and you've got all these other branches people are experimenting on. My branch, Josiah's branch, anyone's branch, they're all doing stuff. But we've got this one version that's going to work, right? And that's always master. They call that master. And
you could have an infinite number of branches all based on the same file. You're only ever going to have one file. And not only that, each branch has its own history of what makes it different from the other branches. So it's an amazing organization tool just for working personally. And I've actually used it for writing papers. I don't ever work in like a Word document anymore. I just write text in like Markdown. And I do like a final branch, I do a draft branch, I do I'll have a thought, like maybe I want to explore this topic instead, so I'll create a branch for a whole new paragraph. And you can really start to keep track of all the different things that you're doing in a really, really succinct and easy way.
Okay. So again, you can toggle between your branches. I just did git check out my branch again, and I can see on that particular file that I get my this is experiment text back. And so we've got these two branches going in our repository, right? The question really is at what point do we want my experiment to become reality or the norm back on the master branch? And so if I'm working on a branch, branches really are supposed to isolate code until it's ready to be merged. And so if you want to merge code back to your master branch, you just create a pull request. So if you look in GitHub for your branch, there should be a button that says compare and pull request. So over here, you can see my branch. I'll do compare and pull request. And what you do when you have a pull request is specify this branch, my branch, where should it go into? And I want it to go into master. And GitHub tells you that you can merge them together without a conflict. And so I open a pull request by just clicking create. And so typically, the way software development teams work is that everybody's working on something new. I'm working on adding this new feature, Josiah's working on something else. When I'm done, I probably haven't thought about the ways my code could break, or the ways that it's wrong, or the way it functions on someone else's computer, right? So when you create a branch, you create a pull request, and you typically nominate someone to review it and merge it, because that gives an extra set of eyes on what you're doing. And so like my pull request, I would probably nominate Josiah to review it, and he could add comments about it. This code doesn't work on my machine. This code looks great, whatever the case may be. But that's kind of the tool when you get more into a workflow with multiple people. Everybody sets up in their own branches and has someone else review it through a pull request.
I'll give like an example. So he's done some work here. He has this branch. You can't see my screen, but when I come in here, I get a notification. There's an open pull request. Someone's made new changes and they've opened a pull request. If I come in there, I can actually go and comment on the specific line and say, and you'll see this pop up on your screen in a second.
Yeah.
Why do we need this line? And I'll add a single comment. Now he should get a notification over here if he refreshes.
Yeah.
In his pull request, I've come in, I'm looking at the code, it's not yet a part of master, and I can ask him questions. And I can review it, and I can say, why do we need this here? Oh, this is really great. We should merge this commit, maybe not this commit, and we go through. And there's this organized way that everyone can be involved in the conversation. So this kind of goes back to what you said earlier. Do we need to set up the rules and everything like that? No, we let GitHub do that for us. You can actually set up certain members on repositories to only have merge power, right? So there's only going to be a couple of people that actually have the authority to merge a pull request, and then you designate other people, contributors. The contributors can open pull requests, but they can't close them. And that's the software handling that for us. If someone comes into the group, they say, I want to contribute, that's great. We've never worked with you before, we're going to give you the right to contribute, but now actually merge the questions. So he would come in, yeah, I have this experimental idea, blah, blah, blah. I come in, I can mention anybody else I want, I can call in people who know way more than blah about me. I can say, hey, can you look at this? They'll write their comments. Now we have a history of what does everyone think about this? And then finally there's going to be one person that actually has the rights in the GitHub account to merge the pull request.